Welcome to lesson 10.1. We're graphing quadratic functions in the form of ax squared, and we're also graphing quadratic functions in the form y equals ax squared plus c. A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a is not 0. And we say a is not 0 because if a were 0, we wouldn't have an x squared, and then think about what the graph would look like. It would be a line. So you want to make sure that you do have an a value, which is a coefficient of x squared, in order to have a quadratic function. This is called standard form of quadratic function. So again, we have greatest degree to least degree terms. The shape of a quadratic graph or quadratic function is called a parabola, and it's that U shape that we get. An axis of symmetry is that line. It's that imaginary line. It's kind of like a mirror. Think of it as a mirror that goes right down through and cuts the parabola in half. Each side it looks like the other from that axis of symmetry. And so we find that axis of symmetry, which is a vertical line, by using the formula negative b over 2a. So what you would do is you take your b value, whatever that number might be, and you make it negative. Okay, so if this sign here was a minus, then you would end up having a negative b, which would be, and then a negative, which could make it a positive. So you kind of have to watch with things like that. You take your b value, make the negative, and then divide it by twice the a value, and that will give you your axis of symmetry. So then the vertex, in order to find the vertex, that vertex is that point. It's the only point that doesn't have a reflection on either side of the axis of symmetry because it is on the axis of symmetry. So you take that x value, which whatever number this is, and you plug it back into the formula and you find the y value, and that's going to be your axis or your vertex. And then you have a minimum or a maximum, and depending on whether the graph opens up, you'll have a minimum. If you have the graph opens down, you'll have a maximum. Let's look at a few quadratic graphs and see what I'm talking about. So here we have two quadratic graphs. We've got a parabola that opens down. So this point right here is going to be a maximum. And we can kind of see that that point is 1, 2. Okay, so that's the maximum because, again, the graph opens down. So this is going to be the highest point, and its vertex is going to be 1, 2. Now over here, the graph opens up, so we have a minimum. And in this case, the minimum is going to be 2, negative 4. And you can see how, you can also see here how the axis of symmetry is going to be this imaginary line right here. And I like to sometimes draw those in with a dotted line. And this is going to be x equals 1. That's that imaginary line, that axis of symmetry. Over here, x is going to be 2. And you can see that imaginary line, or visualize that imaginary line that's happening there. Okay, so our vertex is 1, 2 here, and it's a maximum, and our vertex here is 2, negative 4, and that's a minimum. Let's look at graphing some equations here. With quadratic functions, one way to graph them would be to take and place your, pick an x value pick an x value, and then find its y value and plot those points. So we can see here that we have, if we plugged in a 2 for x, we'd have to square it and multiply it by 3, and we get 12. So 2, 12. And that's kind of be way up here. And then if we picked a 1 and we squared it, we get 1 times 3. So that's 1, 3. So that's going to be 1 point on this y equals x squared. If we picked 0, we'd get 0. And if we picked negative 1, now think about negative 1 squared is a positive 1, and multiply it by 3, we get 1, 3 as well. And then if we plugged in negative 2, we get 12 as well. So you can kind of start to see these 3 points. Now you have to remember that it is going to make a parabola, so it's going to kind of come to a point and come back up. Okay? That's our y equals 3x squared. Now, with our y equals 3x squared minus 2, if we start to do the math here, we plug in a 2, and we get 4 times 3 is 12, minus 2 is 10. And again, that point isn't visible on our coordinate plane right now, so we won't plot that. But when we do put a 1 in, and we do the math, we end up getting 1. So 1, 1 is going to be our point here. And then if we plug in 0, we get negative 2, which is going to be down here. And then if we plug in negative 1, we're also going to get 1. So you can kind of see this parabola taking shape again, and pardon my very, very poor drawing skills here, but it is going to be basically shifted down 2. So you can see if you just had the 3x squared, you get a normal parabola, okay? It's kind of skinny because it has a 3 here, and its origin, at the origin is its vertex. Then when you subtract 2 from it, what ends up happening is it shifts down 2. Okay? And you can graph both these equations on your graphing calculator, and you can see the tables as well, and that will help confirm your graphs. So let's look, go ahead and try the quick checks, and when you're done in class, compare your quick checks with your classmates, and then you can kind of come back to this video and check and see if you've got them right. So here with our first quick check, we have a maximum, and it's going to be 4, 3, and you can kind of visualize that axis of symmetry happening right here, okay? And then here you've got a minimum, and it's negative 3, negative 3, and again, I just drew your axis of symmetry. Now, what's going to happen here with if you were to compare these two graphs? Here's your standard y equals x squared. So if you had a coordinate plane, and again, this is going to be a very rough sketch here because my graphing ability is not the greatest on this software. But we know that our origin, let me pick a different color, our origin for the x squared here is going to be the origin is going to be 0, 0, which is going to be our minimum. And then if we have 1, that's going to be 1 and negative 1. And 2 is going to be 1, 2, 3, 4, and 1, 2, 3, 4. And so you can kind of see here, this is the x squared. This is a standard x squared parabola. And then what ends up happening is 1, 2, 3, 4. In our x squared minus 4, it's going to start at negative 4. 1, 2, 1, 2, 3, 4. It's going to start here, and it's going to go like this. And you can kind of see how it mimics the x squared, but in this case, it's going to be lower. It's going to start at negative 4, so it's shifted down 4. Okay? In B here with the critical thinking, you want to think about what the positive values and negative values of C do to the position of the graph. So if you think about it, a positive value is going to shift the graph up if your C value is plus here, and if it's minus, it's going to shift it down. All right, let's try one real-world application here. So we can see that we have a monkey, and it's dropping an orange from a branch that's 26 feet high. The force of gravity causes the orange to fall towards the earth. But again, you know about the law of gravity, and that it's not going to fall at a linear rate of speed, but it's going to fall more in a parabola rate of speed. So in this case, with this, notice we have this negative a value here. So we know it's going to be an upside down parabola, and it's going to look something like this. Now, because it's a real world situation and we can't go back in time, we only graph really the first quadrant here. And we can see how the graph is going to start out at 26, and it's coming down at a rate, and then when it hits this x-axis, that's when the orange hits the ground, okay? So if you look at that, we can, again, pick values, and notice with time here, t, I picked some small increments because it's falling, the orange is falling pretty fast. And if we pick some small increments and again plug it in, we can figure out the height. And then what most importantly, we kind of can figure out when it's going to hit the ground. And you can do that by also plugging this equation into your graphing calculator. And then in the second equation, to look at where h equals 0, okay? And if you plug h equals 0 into the second line of your graphing calculator and then use your intersect button, second calc, intersect, and then you press enter until it finds the meeting spot, it will show you what time it actually hits the ground. Okay? Now, in the quick check here with quick check 3, we can look at, now we've changed the starting value, which is now only 24 feet high, because we have a squirrel and he's dropping an acorn instead of a monkey throwing an orange. And with that function, again, we use h as the height, and then t squared is the time that we're going to plug in. Now think about a domain and range. Remember, domain is your input and range is your output. So again, domain, we can't go back in time. So time values, we're going to use 0 to probably a little bit after when it hits the ground. So we know that it hits the ground. And then our height, obviously our range is going to be, it's going to start out at 24. That's going to be our maximum. And then our minimum is probably, we're going to be looking at our range of about 0, because after it hits the ground, it can't really go underneath the ground. I mean, it could, but again, reasonable domains and ranges here. So you want to be looking for those kinds of numbers when you're doing a problem like this. Go ahead and graph it on your graphing calculator. Take a moment to make a nice quick graph here as well, and discuss it with your table mates when you're done. Thank you.